In 2018, the world's greatest construction project went silent. 820 feet of concrete and steel abandoned in the Saudi Arabian desert. The project meant to dethrone the Burj Khalifa had become a skeleton. Not for lack of money or technology. The project stopped because physics presented a bill nobody had calculated correctly. 1 kilometer straight up. This isn't just an engineering barrier. It's a challenge for everything nature doesn't give away for free. Wind that dances, ground that sinks, concrete that won't rise. Every foot above 1600 is a different problem. In this video, we'll break down every single one of those problems and the solutions that brought this tower back to life in 2024. If you're into engineering the way it really works, no easy answers, no clean blueprints, subscribe and hit the bell. This is the kind of story we tell here. The Jeddah Tower is alive again. The question now is, will physics allow it? For 4,500 years, the tallest structure ever built by human hands was a pyramid in the Egyptian desert. 479 feet, stone upon stone, without motors, structural calculations, or computers. That record stood for 3,800 years, until an English cathedral in 1311 surpassed the pyramids by a mere 46 feet. In 1889, Gustave Eiffel doubled the cathedral's height using iron, nearly 1,000 feet in 2 years. The world had no answer. 42 years later, New York answered with steel. The Empire State rose 1 floor per day for 14 months. Each generation pushed the limit with the material of its time: stone, iron, steel, reinforced concrete. In 2010, the Burj Khalifa redefined what was possible. 2,700 feet, nearly double anything that came before it. For the first time in history, a building was so tall that the weather at the top was different from the weather at the base. 15 years later, on the other side of the Arabian Peninsula, a city called Jeddah decided that wasn't enough. The plan: 3,307 feet. The first human structure to break the 1 kilometer barrier. 1 billion pounds of total weight, 17.5 million cubic feet of concrete, 88,000 tons of steel, 270 foundation piles driven 344 feet into the ground. 344 feet. To anchor this tower, engineers had to bury the equivalent of a 30-story building below ground level. Except the ground here isn't solid rock. It's marine coral, porous, salt-saturated, corroded by the waters of the Red Sea. The foundation was only the first problem. 2 more were waiting above. The soil along Jeddah's coastline is among the most treacherous in the world for construction. Fragmented marine coral, saturated with salt water, riddled with invisible cavities. The Red Sea carries chlorides and sulfates. In contact with conventional concrete, these compounds trigger a slow chemical reaction and destroy the structure from within. The solution was to reinvent the concrete itself. Silica fume, corrosion inhibitors, and specialized additives turned each pile into a component engineered to last centuries in that environment. Foundation solved. Now the second villain stepped in, and this one lives in the air. Above a certain height, wind isn't just strong. It organizes itself. When air meets a continuous vertical surface, it begins releasing alternating vortices from each side. The technical term is vortex shedding. These vortices create alternating zones of pressure and suction, pushing the tower sideways in rhythmic pulses. If the frequency of those pulses matches the tower's natural vibration frequency, the building enters resonance. That doesn't bend steel, it breaks it. The answer from architects Adrian Smith and Gordon Gill was a Y-shaped floor plan. 3 asymmetric pedals, inspired by desert plants native to the Arabian landscape. Each wing of the tower ends at a different height. The wind never meets the same surface twice in a row. Vortices still form, but out of sync. And without sync, there is no resonance. The shape isn't aesthetic, it's aerodynamic. The tower outsmarts the wind through geometry. If you want the current world record holder on your shelf, while the Jeddah Tower races to catch up, the Lego architecture Burj Khalifa set is one of the best ways to feel the scale of these giants up close. Link is in the description. Third villain, the quietest of the three, and the one that has derailed similar projects throughout history. How do you move liquid concrete to 3,000 feet of height before it sets? Concrete begins hardening the moment water and cement meet. In the Saudi desert heat, that process accelerates. A mix that would take hours to cure can become useless in minutes. The solution required pumps capable of generating over 2,900 pounds per square inch, the equivalent of nearly 200 atmospheres, forcing concrete upward through steel pipes. All concrete pumping at the Jeddah Tower happens at night. With lower temperatures, the chemical reaction slows down and the working window opens. The temperature difference between the base and the top of the tower can reach 18 degrees Fahrenheit. In practice, two entirely different climates inside the same building. There is a fourth problem, one that only appears once the tower is finished: the elevators. Above 1,600 feet, the weight of a steel cable becomes its own worst enemy. The Jeddah Tower will use Cone's UltraRope, a carbon fiber core cable 90% lighter than conventional steel. Light enough to travel 160 floors without snapping under its own weight. Then there's the stack effect. At 1 kilometer of height, the pressure difference between the base and the top generates a violent internal airflow. Left unchecked, the entrance doors would be impossible to open. The solution is pressure chambers in the lobbies, seals that gradually equalize the difference before each access point. The same principle used in submarine airlocks. Between 2014 and 2018, the Jeddah Tower grew at a relentless pace. 63 floors, 820 feet of height. Engineering was winning. In 2018, everything stopped. Not because of a physics problem, because of a power problem. The project's lead financier, Prince Al-Walid bin Talal, was arrested during the Saudi government's sweeping political crackdown. The construction company responsible for the build, the Bin Laden Group, filed for bankruptcy. The world's most ambitious tower became a ghost site. For 6 years, the desert reclaimed the silence around the structure. In 2024, new contracts were signed. 14 global firms entered the bidding process to resume the build. The challenge now is completing the 1,300 feet of concrete still missing, and then raising the entire steel superstructure at the top. The final 1,000 feet will be built entirely in ultra-high-strength steel. Above a certain altitude, pumping concrete stops being viable. Steel goes up by crane. There is a detail very few projects have ever had to calculate. With 1 billion pounds of total weight pressing down, the concrete at the base will compress. The tower will shrink by roughly 3 feet over the coming decades. Engineers have already accounted for this. The upper floors were designed slightly above their final target height, so that when compression occurs, the tower lands exactly where it needs to be. On the 157th floor, there will be an observation deck nearly 100 feet in diameter, the highest in the world. Originally designed as a helipad, from up there, on clear days, it will be possible to see the curvature of the Earth, not as a metaphor, as a geographical fact. The tower is just the beginning. Around it, the Jeddah Economic City is taking shape, a $20 billion project turning the surrounding area into a city built from scratch. If everything stays on schedule, the Jeddah Tower will open before the end of this decade. The first human structure to break the 1 kilometer mark. Every generation picked a limit to break: stone, iron, steel, concrete, carbon fiber. The material changes. The ambition never does. The Jeddah Tower begins 344 feet below the ground and ends 3,307 feet above it. That's 3,651 feet of continuous engineering, from bedrock to the clouds. it will shrink 3 feet under its own weight. The engineers already know this, already calculated it, already compensated for it. That is what precision engineering looks like. Behind every number in this video, there are people waking up before sunrise in the Arabian desert to push 1 more foot into the sky. When it's finished, it will be visible from 37 miles away, a needle of steel and concrete piercing the Arabian sky. The 1-kilometer barrier isn't just a technical threshold, it's a statement, proof that the limits of what we can build have not yet been found. If this kind of engineering moves you, you'll want the current world record holder on your shelf. The Lego architecture Burj Khalifa set is linked in the description. One of the most satisfying ways to hold the scale of these projects in your own hands. If this video changed the way you see engineering, the like makes a real difference to the channel, and subscribing makes sure the next one finds you. The Jeddah Tower is still rising. Physics tried to stop it. Politics tried to stop it. The desert tried to stop it. For now, engineering is winning.